There we go. Oh, for crying out loud.
What are you doing?
I don't know.
I'm talking to the computer.
We're talking to the computer. Okay, there we go. Now we're back. Hi, everybody. Welcome to this week's Learning Space. We are your hosts, George and Nicole. We are all together in one office because my computer's still gone with a dead hard drive. Very exciting. So welcome to this week's Learning Space. First off, I want to thank all you guys who have been donating or sharing or retweeting our Giving Tuesday requests. We're still getting some donations in, which will help us out greatly, so thank you. Awesome. If you haven't already, check out the blog. Pamela wrote a blog post fairly recently about the funding woes going on across various NASA programs. So if you can help out, check that out.
Yes.
I can tease maybe that we have a Patreon account starting soon, which will help fund some of these video broadcasts.
Yep, exactly.
So we'll be doing that.
So keep an eye out for that.
Anything else? Announcement-wise?
That is really the big concern at the moment. So, to put it that way. Yeah, I think that's it.
Okay, cool. And so today we are going to be talking about WorldWide Telescope. We have Patricia, and I forgot to ask you how to pronounce your last name before we went live.
It's Udon Persert.
Udon Persert. No, I didn't do it right.
Wow.
Udon Persert. I shouldn't be talking. My last name's Gugliucci. But
You're saying that. I wasn't sure how to say yours either.
So thank you for coming on the show. We wanted to show people a little bit about WorldWide Telescope and specifically ask about how that works in the classroom for educators or with the WorldWide Ambassadors Program. Before we get into that, I want to remind you guys that you can use the question and answer app, the Q&A app, anywhere you're watching this on YouTube or Google Plus or anywhere that it's embedded. I forgot to embed it on the CosmoQuest site. I think it's over here, somewhere over here, somewhere over here. One of these places, there's a yellow button that says join the conversation, and you can click there to join the Q&A app. And leave some questions. So we have hellos from Nancy and Guido and Elon. So hi, everybody.
Hi there. Good to see everybody.
There's also usually some general chatter happening in the comment threads on the event pages. I will try and check in on that every once in a while. But if you want a question or a comment for the show, make sure you use the Q&A app. So why don't we jump into the topic, Patricia? What the heck is WorldWide Telescope?
Got it. Okay. So WorldWide Telescope was a program that was developed by Microsoft Research, and it's designed to visualize all of the imagery that astronomers have ever taken with telescopes all around the world. And it was released in 2008, and it's grown and grown over the last 6 years to include many powerful and exciting features, which makes it a wonderful tool. It can be overwhelming to some people to learn. 12-year-olds in classrooms, we find, are not part of the group of people who feel overwhelmed by it. They just jump right in. They think it's amazing and awesome. We have a 12-year-old boy who said in front of his entire class, wow, this program is cooler than Call of Duty.
Ooh!
So,
wow!
So let me jump in right here with a screen share so I can start showing and not just telling.
So you guys know if you're using the
share my screen. WorldWide Telescope is not coming up as one of my choices for what I'm allowed to share right now. So,
is it full screen on one of your desktops?
I don't think so. Hold on. Let me try this again. Sorry.
That's fine. It's worldwidetelescope.org, and we've got the link in the Showcase app right now.
Super. Okay.
Hey!
Okay, there we are. Okay, so there are many different views, and the default view that you see when you launch the desktop client in Windows is this view of the solar system. Now, it was named the solar system view back when it only had the solar system. And then once they built the 3D engine to render this model, this fully accurate model that works in real time, so this is where everything in the solar system is at now, this point in time. they realized, oh, we have the Hipparcos catalog of stars where we have accurate parallax measurements. We could throw those in. We can throw in a beautiful model of the Milky Way. We can throw in galaxies from the Sloan Digital Sky Survey. So I'll gradually step outwards and show you all of those things. I can also show the sky view where you can look at the entire electromagnetic spectrum, all sky. And then there are panoramas from Mars and the Moon, and there are really beautiful Earth-based and other planet-based views. So let me just start here. If you click on any of these thumbnails at the bottom, it will take you to objects of interest. I find that a lot of people are really happy just starting at home.
Nice and familiar.
When I give these demos, especially I find the younger the students that we work with, so we do a lot of these kinds of demos at public events like science festivals. We do a lot of work in classrooms, and every kid eventually goes back to trying to find their house. But
all different Google Maps first came out, or Google Earth.
Yeah. So the Earth-based views get compared a lot to Google Earth. This is, I think, from Bing Maps. Okay, so you can give the whole context. You can show how the Earth orbits the Sun, how the Moon orbits the Earth. So we've designed some curriculum units. We had some NSF funding to develop a module that teaches middle school students why the moon has phases. So we're trying to move beyond just looking at pictures and memorizing what name goes with which picture, or doing the Oreo cookie thing where it is delicious and fun, but it doesn't actually teach you the science behind why the moon has phases. So here you can show that because the sun is over here, it's lighting up this daytime side of the Earth and this daytime side of the moon. And if you spin around, you can see this is the nighttime side of the Earth because it's facing away from the sun. And you can show that the moon here also has a nighttime side. And the phase that you see just depends on how much of the daytime versus the nighttime side of the moon happens to be facing the Earth. And I can step forward in time. So this is actually all moving in real time right now. So the Earth is turning at a rate of once every 24 hours. So most people don't want to sit around and wait that long to watch the Earth spin. So if you click this button, every time I click it, everything speeds up by 10 times.
Okay.
So now you can see the day and night happening. You can see the moon going around really pretty slowly compared to a day-night cycle. So we've now advanced by just a couple of days, and we now would see a gibbous moon. And if we advance by, say, a whole week, oops, I overshot. Fly. I overshot full.
So how long does it take to really get good at maneuvering around in this view?
You know, it really depends person to person. So people who tend to be pretty comfortable with gaming environments where they have to manipulate different views from overhead, first-person perspectives, they tend to just jump right in and go. I don't like to make generalizations because there are always exceptions, but we find that you know, a lot of teachers that we work with tend to have a harder time picking it up. Like they're just afraid that they're going to click the wrong thing and something's going to break. Whereas, you know, as I said, kids just have no fear.
Yeah, we see similar things with Crater Marketing Cosmo Quest, to be honest.
Yeah.
Kids jump right in.
Okay, what else can I show that is awesome? Jupiter. You know, a lot of people know that Jupiter has many moons. When I was in college, I think the moon count was only something like 17.
Oh, wow.
And now it's something like 60 plus. I forget 60 what exactly. But that's just a number to most people that they memorize or they read it somewhere, like, sure, that's nice, 60-something moons. So you can actually visualize what it means.
Whoa!
Yeah, to have 60-something moons. And you can talk about the physics here. So you've got a bunch of moons that are in this organized plane, and then you've got a lot of other moons that are crazy. Yeah. So you can talk, if students have learned about conservation of angular momentum, you can talk about how we think the ones that are in this organized pattern formed with the Jupiter system, and anything else was captured later or hit and kicked into a funny orbit. So you can zoom out, you can see other planets that also have big moon systems. There's Saturn. There's a little screen share button that's hiding my bar here, but I think I can work around it. Uranus spins on its side, and so do many of its moons.
Look at this mess.
I know, it's a big snarl. It's a big snarl in space.
There we go.
Look at that.
That still baffles me.
That's impressive.
The whole system is tipped like that.
Isn't that crazy?
That still baffles me.
Makes you want to tilt your head and look at it. Wait.
I see it. Yeah. Shout out to the virtual star party. I see it.
Awesome. Wow.
A lot of students the middle school students that we work with now, a lot of them never knew that Pluto was ever a planet. Oh. So I'm getting fewer and fewer angry students.
Yeah.
Lots of questions about Pluto. But for the kids who are, or even the grown-ups who are still upset about Pluto, I find that letting them explore this view, they notice. They're like, what is that thing that's not in line with everything else? Mm-hmm. And once they figure out that it's Pluto, then they start to kind of think, okay, well, there are differences. Yeah. And I'm just going to go back to the sun view, and I'm going to turn on the asteroids. And it doesn't make my whole computer grind to a halt.
Oh, cool.
So so you've got the Kuiper Belt out in white. I don't know how well all the little dots are coming through in the screen share, but this kind of helps the students that I talk with who've like memorized the 3 parts of the definition that the IAU voted on to become a planet, and they don't really know what they all mean. So one is that you have to orbit the sun, one is that you have to be big enough to have gravity pull you into a roughly round shape, and the third thing is that you have to have cleared the neighborhood around your orbit. And kids are like, I don't know what that means. So we can use this to sort of show them that clearing the neighborhood around your orbit basically means that you're by far gravitationally the most important thing at your orbital radius around the sun. So Jupiter has all kinds of other stuff around in its same orbital radius, but it's by far the most gravitationally important thing.
Jupiter has several posses.
Sorry, I didn't hear that.
I said Jupiter has several posses. It's got little like followers. It's got the Trojans and the what are the other ones? What am I missing?
I don't know.
Somebody yell it.
The only ones I know.
Somebody yell it in the comments. We have some comments including, that's no moon, it's a mouse nest. That's awesome. And then Nancy says it looks a bit like an electron cloud around the nucleus.
Yeah. Okay, so I'm going to turn off the asteroid now, and I'm going to keep going out. So I mentioned... Sorry, are there questions that I should...
We have a couple questions about the version. So Guido says he can only run an old version, a legacy version. And Eli looks like he's looking at an old version as well. What are the computing requirements to run this on your machine? How do you?
Yeah, that's a good question. So the desktop client that runs in Windows is built on the DirectX gaming engine, which is why it looks really beautiful. It's basically, if you have a computer that can run video games that are graphics intensive, my telescope will run well on that. Yeah. And we have a bank of laptops that we take around to schools just so everything is set up how we like it to be, and they're not that fancy. So there's a list of system requirements. If you go to the worldwidetelescope.org webpage and you go to the link that says download Worldwide Telescope, there should be a link there that tells you what you can and can't do. And the legacy version of Worldwide Telescope should still be really good.
Okay.
There's also, if you're not running a Windows computer, there's a web client that you can also access from the worldwidetelescope.org webpage. And that runs on anything. You can run it on an iPhone, you can run it from a Linux machine. There are certain features that they couldn't fully enable in the web client because you know, a lot of the graphics, like the really seamless, beautiful graphics, need something more powerful than what you can access through a web interface. But they've rendered the solar system model in the web client, and you can see like the polygons that make up the spheres. So you can teach the same general ideas.
Right.
Okay. Let's see. So let's go find a familiar constellation.
Ooh, I know that one.
I see one.
And you know, a lot of people just don't get that different stars have different distances. They sort of have, there's this common misconception that everything that's part of a constellation is close together in space, not just in the sky. So you can show that, you know, different, the shapes that we see have to do with the projections of the 3D patterns of the stars to you know, what we see from our position in our galaxy. So you can actually click on any of these objects. If you right-click on them and you click Show Object, then you can recenter the camera on that particular object. So I am taking us to Alnitak.
Ah.
And let's see. You have to let it stop before you can do anything. So I'm going to roll back and I'm going to try and reconstruct. This is basically what Orion looks like from our point of view. And if we lived somewhere else in our galaxy, say here, you can show how the shape of the constellation that we would see would totally change. And you can see cool fuzzy Milky Way in the background. Ignore the fuzzy Milky Way background for now. So, you know, this star up here is Betelgeuse. The rest of the belt stars are kind of over here. I've sort of lost track.
Yeah.
And if you keep zooming out, you can see the rest of the Milky Way. And this is a brand new model that was put into the latest release of Worldwide Telescope. So if anybody's ever downloaded an older version of Worldwide Telescope, this may be new to you.
Okay.
And actually, one of the things that I don't love about this change, it used to be that the sphere of Hipparcos stars was a very obvious subset of the galaxy. So you could kind of point out that the distances to the stars that we've actually mapped that are part of the constellations that are our familiar part of the night sky, it's actually only a tiny, tiny piece of this galaxy, and that kind of got lost a little bit in the addition of this model. But I do love this model. It's beautiful.
So we have another question from Elad. I see the program has the option to connect to a telescope. Can you elaborate on that feature?
Yes. I have only done it with one telescope here at Harvard on our rooftop. So I don't know if you're asking about exactly how, like, what happens when you do that, or so basically what you can do is you can do a go-to, like, so if you look for something in the sky view in Worldwide Telescope, which I'll show you in a little bit, then as part of the telescope controls, and you click go-to, and then it'll take your telescope to the thing that you're looking at in Worldwide Telescope. And the coordinated view is really neat because I'll show you in just a little bit. There's some pretty powerful research tools that let you get access to a lot more information about the objects that you're looking at. So it's a great way to supplement star parties. So if you've got a line of people waiting to look in the telescope at the object that the telescope is pointing at, you can have everybody else kind of looking at other information about the object that they're going to get to see when it's their turn to look in the telescope. Okay, I've zoomed out now to the Sloan Digital Sky Survey. And let's see. I don't know how well all these dots are rendering in the screen share, but you should see kind of this bow tie-like shape. And it's actually kind of a lot of work to convince some people that the universe is not actually shaped like a bow tie. That the map is constrained by what we're able to observe easily from our point of view inside of a flat circular galaxy.
Yeah.
So I'm taking us to the Coma cluster.
Ooh.
Pretty.
So we live in kind of a galactic suburb.
We do.
But this is one of the big cities of Galaxy.
Yeah, we're pretty rural, aren't we?
We're pretty rural, actually. I think rural is more like it. It's us and the Andromedans next door.
So, this view was great for teaching people about how important gravity is. So the early universe was this almost completely uniform sea of gas, and there were little pockets where some places had just a tiny bit more gas and some pockets had just a little bit less. And the more stuff you have, then the more gravity you have, and you start to attract stuff away from the less dense areas. And the rich get richer and the poor get poorer. And that's how you end up with this cosmic webby structure of filaments and voids, which you can see in this view.
Not quite clear coming across on the screen share. You guys may have seen that before.
Okay.
That kind of
we can go and try this at home.
spongy, webby, yeah.
Does that show better, the spongy webby?
Oh, there we go. Yeah, that's showing a little bit better now.
Yeah. And then if you keep zooming out, then they've got the cosmic microwave background.
There's the bow tie. So.
Oh, okay.
Actually, if I turn that off, that might actually make it easier to see the webby stuff.
There we go.
Is that clear?
Yeah, so that's the Sloan Digital Sky Survey. Millions of galaxies mapped out from a telescope in New Mexico. Huge data available to the astronomical community and to the public.
Okay, I'm going to just zoom back out one more time, page up, and just to show why the map has that funny shape. So this is usually a pretty good demo for kids who are worried about the bow tie shape of the universe. So you can see that the missing wedges in the map correspond to the plane of the galaxy.
Right.
So you're not going to be able to look in this direction or in this direction very easily for galaxies beyond ours because you're looking through all kinds of gas and dust and gunk. Right. Whereas if you look up this way or down this way, then there's lots to see. And then we also have to take care to make sure people know, yeah, the edge of that is just the edge of this map. This is not the edge of the universe.
Yeah, so that's how much of the universe, the volume, that we've so intricately mapped.
Yeah. Okay, so let me move on to the sky view. So this is a view that I think more people tend to be sort of familiar with in like night sky planetarium kind of software. So we've got this, the default view is the digitized sky survey, which early releases of WorldWide Telescope you could see the tiles of the different plates that made up this map. And Jonathan Fay, who is the principal software architect for WorldWide Telescope at Microsoft Research, he figured out a way to smooth over the entire map and get rid of all of those seams. So now you have this beautiful, beautiful image. And you can just keep zooming in, and as you zoom in, then you're loading higher and higher resolution versions of these images. So you can get to really great detail. And so to do this, it's helpful to have a pretty good internet connection.
Mm-hmm. Okay. Oh my gosh. And when you said plates before, that's digitized huge photographic plates that they used to use in astronomy.
That's right.
To survey the sky.
Let's see. Okay, so overlaid on top of this DSS map, you can have other images that have been curated by WorldWide Telescope. So as I zoom in, this bottom bar updates to show things that are of interest in the field of view. So I can click on any of these things.
So I'm not sure the bottom bar is coming across on the screen share, but if you guys are playing along at home, that should be right under the image that we're looking at now.
So this bar doesn't show up?
No. Huh. But the effects of it.
Okay, interesting. Thanks. Thanks for letting me know. That's helpful. Okay. So one of the things that I really, really like about being able to view these images in WorldWide Telescope is that you're able to see them in their proper context in the sky. So this view in the Orion Nebula, this has probably been on magazine covers. I've seen this image, for a long time. It's a very famous image. And it wasn't until I looked in WorldWide Telescope that I even really knew what part of the sky I was looking at and how much of the nebula you're seeing when you're looking at this picture. So we're in Orion. We're in the Great Orion Nebula. That's basically where the sword is. And then you've got this image that is just a pretty small piece of this big cloud. So I like that context and being able to know, oh, that's the little patch of sky that we're talking about. And this globe also shows you what your field of view represents. So this yellow rectangle, which maybe isn't showing either if the context bar isn't showing, shows you how much of the globe, the celestial sphere, basically, you're looking at. Okay. And so the images, if you see things that look interesting to you, you're able to access lots of links to find out what they are. So if I right-click on the thumbnail for this image and I can click Properties, does the Finder scope appear? Did that just show up?
No.
No.
Yeah, it's only showing the single window. If you screen share the whole desktop,
maybe I should do that. Hold on, let's see.
Show us that.
I'm going to stop sharing, and then I'm going to reshare. Screen share entire screen. Okay, let's try that.
Ah! Oh, there we go. Yay!
Okay, so there's the bar, the mysterious bar I was talking about. There's the globe with our showing how much of the celestial sphere we're looking at and which direction we're looking in. And then here is the Finder scope that gives you information about all of these images that are down at the bottom. So every image should have a link to where this image came from. So this image is from the Hubble Space Telescope, and this links you to the press release that talks about what this image is and why this image is important and famous, and you can do that for anything. So not every image has been curated by a team of EPO professionals who give lots of good for the public information about the images. So you kind of have to pick and choose. And I think all the links to anything from Spitzer might still be broken. The whole collection got pointed to a different URL, and they haven't figured out. I should try one just to see. I could be wrong. They may have fixed it, but it was incorrect for a long time. But I mean, and things that come from smaller telescopes that don't have EPO teams, they might not go to anything particularly useful to the public. Okay, so other things you can do. So if you click on something that's just sort of a more generic version, Orion Nebula, you can also send this information to lots of different engines. So you can look it up in Wikipedia, and this will give you, it will send the string Orion Nebula to Wikipedia, and it will bring up this page. You can also look up whatever scholarly publications astronomers have written about the Orion Nebula on ADS. 3,406 articles.
Probably a few.
Old ADS.
But I'm just going to caution that you want to use the generically named thing, like Orion Nebula, if you want to do that, because this one that is called Hubble Probes the Great Orion Nebula, it would send that string to Wikipedia, and Wikipedia would be like, I don't know what Hubble Probes the Great Orion Nebula is. So there are just certain quirks, because this is a huge database, and you kind of have to know what will work and what won't work.
So we have a question related to that. Does WorldWide Telescope include updates on current ongoing stuff, like newly discovered comets, or is it hard-coded in every version and updated? And then Sylvan Westby also adds, is there links to databases like Minor Planet Center or Simbad, which you showed? But what about like the objects in there? Are they updated frequently? Is it?
That's a great question. So there, I would say for the most part, it's not frequently updated. So whenever there's a new version of WorldWide Telescope released, then whoever has been, whoever in the astronomy community has been working closely with the WorldWide Telescope team to curate their data in a form that WorldWide Telescope understands, and works with the team to kind of create and update the database, those things tend to be updated with each new release of WorldWide Telescope. And this is a very new release, like in the last 2 or 3 weeks. So what's there right now should be pretty current. But as I was saying, that not every astronomy team has the staffing to curate the data in a way that WorldWide Telescope understands. So you'll find that there are a lot of things that you want to search for and look for, and WorldWide Telescope actually doesn't know about them. And it's not because WorldWide Telescope doesn't care about them, it's because the people who work in those areas didn't have enough money to fund somebody to help work on this with WorldWide Telescope. Does that make sense?
Yeah, absolutely. Unfortunately, it makes a lot of sense to us.
Yeah, and I wish it were different, and we're hoping that going forward we'll be able to have much more active community participation around making sure that databases across all subfields of astronomy are current. Okay, so I am going to
some amusing comments I have to share. Elad Evern says that if they had this on Battlestar Galactica, it would be a whole different show. Guido Bibra says that looks much more like the version I have installed. Simply said, it's an Encyclopedia Galactica. I like that.
Excellent.
And Nancy Graziano says, I better steer clear of this app until I have completely retired from my job. If I you'll get absolutely nothing done ever.
That's why I feel very lucky to have the job that I have, because it actually is my job to get lost in this program and figure out all the gee whiz things it can do. It's very lucky. Okay, so what I have done here is I've pulled up, hold on, let me un-auto hide this thing.
Can I tell you how much I love that there are radio surveys? Like the VLSS is included. Like,
I love that too, but the VLSS is actually kind of lame, and as far as
those are awesome. They look
in my former life, I was a radio astronomer. I was an undergrad intern at the VLA, and all of the radio imagery is near and dear to my heart, and it breaks my heart that NRIO doesn't currently have enough funding to do all the curation that we need to do. So, and we're talking with some folks there, and we're hoping to get all of the beautiful VLA imagery ingested into WorldWide Telescope.
There's a new survey being proposed, and I'm on the committee for their communications and outreach. So I will make sure.
Okay, because I don't want to dump on my subfield of astronomy, but this compared to this.
I get it. I get it. I totally get it.
Compared to this.
That, yeah.
And nobody ever looks at the VLSS. So I'm sorry to say. So I'm going to go back to, say, this says the foreground, this is the background. Okay. So you can talk about why astronomers care about the whole electromagnetic spectrum, and by comparing two different wavelengths. So I have the default digitized sky survey as the background, and I've set as the foreground the WISE all sky survey. So this is infrared.
Yeah.
And you can see the center of the galaxy. It's, you've got this dark dust lane that hides stuff that you want to be able to see. And if you look in infrared, the dust is all shining very beautifully and brightly. Let's see. Sometimes I get myself into a weird state.
Astrophysical dust is fascinating.
It is. And you see this blobby, dusty stuff, and you're like, what is that? Oh, that's Orion.
Yep.
And you're like, oh, okay, so you have to have lots of dust and gas to make new stars, and there's a lot that you can do. There's X-ray. The Rosat map is pretty fun to look at too. So if I set this as the foreground instead, you can look at these bright, bubbly things.
I was gonna say, is that a supernova remnant?
I think that's a supernova remnant.
Space jellyfish. One of the two.
So if you look at this, do crossfade back to the optical, you can see this wispy edges in optical, and you got this bright bubble here, and then you've got this friend bubble nearby that looks more ghostish. And what is that? If I crossfade this thing, I think see this little arc here?
Not really in the screen share, but I believe you.
My arrow?
Yeah, a little bit. Yeah.
So there's a little arc here.
Yeah.
Which, if I had only been looking at the optical image, I never would have known that was there.
Right.
But because you've seen this in the X-ray, you get this hint that there's something else going on over there.
Cool.
So lots of useful things there. I think I want to kind of move on. Okay, Earth views.
Yay!
So, everybody wants to find their house, but you can also do cool things like, I need to have maps help me. I am not geographically so astute that I can just zoom in without the geographical boundaries. Okay, so you can show things like the Grand Canyon. You can go to Mount Everest, and this is a demo where if you happen to have a supply of 3D glasses kicking around,
which you guys give out at AAS conferences,
we do the red-blue one.
Telescope.
Then if you set this to go in the 3D mode, which you do by going View, Stereo, Anaglyph Red Cyan, this demo always blows people away.
Yeah.
It's really powerful. So here's the Grand Canyon. I actually had somebody come and tell me at a science festival event that they went and dug up their pictures from their vacation to the Grand Canyon, and they figured out where they were standing and compared the view within WorldWide Telescope to the view from their family vacation pictures, and they were able to actually match up the background.
That's awesome.
So this is really good in 3D, which I can't show you over the Hangout because you guys don't all have red-blue 3D glasses sitting right on your desks.
Yeah, mine are next door.
You want to go get them? Go get them.
I have WorldWide Telescope red-blue 3D glasses because I have you guys. That's all I have.
I'm glad you have them.
Yeah, because the Mars rovers put them out too.
Yes. Yeah, we can show some of those views too. Let me just find the Mount Everest.
I used to be able to find the VLA on maps really quickly.
Well, I don't know if I've ever tried to find the VLA on this. Okay, so there's Mount Everest.
Whoa. Yeah. Whoa.
And you can see the data streaming to my computer. You've got these tiles where this one is a high-resolution image and this one's a low-resolution image. I think my computer's kind of hit its limit of what it's willing to do for me on the internet. Yeah, so that's the Earth-based view. You can another good one actually is the Earth at night. So this one's
our dark skies awareness. Wow.
Yeah, and this always kind of blew me away is how much more brightly lit the right half of the U.S. is than the left half.
Yep. Yep.
It's like a perfect line right down the middle.
I grew up in that really bright spot of New York City.
Oh, okay. And okay, and then there's also there are these panoramas. So this is where a lot of fun Mars images are. And we don't have Curiosity images yet, so that's another one of those kind of artifacts of, well, there aren't enough people who can curate and corral all of the data that needs to go in here. So we've got older Spirit and Opportunity images. But if you click on anything that has in parentheses stereo after it, it will work with those red-blue 3D glasses. Cool. You can control this with an Xbox controller. You just plug the USB plug for the controller into your computer. You can drive around and navigate. So if you're ever at like a AAS or any other big astronomy meeting where we've got a booth going, you can come and experiment with all that stuff. You can also run this with a Kinect controller.
That I've seen. That is really impressive.
Pretty fun. It's pretty fun. Planet view. You can look in more detail at other planets. So there's Olympus Mons. And this is not that impressive, even though it's 3 times taller than Mount Everest. It's so wide that it just looks it's kind of like a pimple.
It's my science word for the day.
There's Velis Marineris. I like to imagine we're driving the X-Wing fighter down this little...
That needs to be added. That needs to be added.
Yeah, a little model of the...
Yeah, just have like a little model superposed on the screen like you're...
Actually, I could show. I'm not confident this is going to work.
Okay.
Well, let me just make sure I've gone through every view. Earth, planet, sky, panorama, solar system. Sandbox just showed up in the latest release. I don't actually know what Sandbox is.
New things to play with, like X-Wing.
It's not doing anything. I have a blank screen. I'm going to leave the Sandbox for now. You guys can experiment. Actually, I'm not sure if I'm running the official release or an experimental release, so that might be why I have a Sandbox. Solar system. Let me see if I can get the International Space Station. Track this frame. This is very data intensive, so it often takes a very long time for it to appear on a computer that's not just... Oh, there it is.
Whoa!
Oh, I was expecting a little dot.
I'm ready for the little dot, too! Whoa.
We see that. There it
That's
is.
impressive.
So you can make an X-Wing fighter of those and put it on Mars. Who wants to build the model?
So, speaking of building and contributing, we have another question from Eli, who's very excited about this, because he's a computer science student with aspirations to do exactly this or something similar.
Super duper.
So on the website there is a service development kit, SDK. How open source is the database? Can anyone contribute and work on it?
You mean for WorldWide Telescope in general?
Yes, for WorldWide Telescope in general.
Yes. There are plans for a very exciting future for WorldWide Telescope. The plans are currently, there are many, many people involved in these discussions, so I'm not really at liberty to say what those exciting plans are yet, but please be on the lookout. And if in the next 2 months you're still really curious to know what's going on with this and you haven't seen or heard anything publicly, just send me an email.
Okay. Is there like a general email people can contact, or?
So there are different channels for getting in touch with the WorldWide Telescope team. On the WorldWide Telescope webpage, there's a WorldWide Telescope discussion community.
Okay.
And it's not a super active community, but the WorldWide Telescope team does try really hard to stay on top of questions that come in there and answer them. So my role here at Harvard is I run the WorldWide Telescope Ambassadors program. So we're an outreach organization located in Boston, and we recruit volunteers and send them into schools and to public events and to share WorldWide Telescope with other people. And so my role is mostly focused on educational applications of WorldWide Telescope. So anybody's welcome to just email me.
Okay.
If you have questions, especially if they pertain to using WorldWide Telescope in education, or I mean, if you just have general WorldWide Telescope questions and you don't know who to direct them to, if you send them to me, I'm in touch with the team and I can pass them on.
Great. So can we put up your email address in the event page comments?
Yes, that's fine.
Okay, cool, cool. I'll do that afterwards. Awesome.
Nice.
You had I know you've done some educational research using WorldWide telescopes, particularly with the moon phases that you showed before, because that is, of course, a very popular topic for Astronomy 101.
Yes.
Can you talk a little bit about how WorldWide Telescope has affected how people teach moon phases?
Yes. Okay. I can bring up. Okay. WorldWide Telescope Ambassadors. Okay, so this is the website from our group at Harvard. And we just launched this newer version of the website, so some links may still be strange. It would be super helpful to us if you find broken links to please email me so we can fix them. Okay, so research. Okay, so we had some NSF funding to develop this 3-day unit, which we used with middle school students. And we don't think that this has to be restricted to middle school usage. I think a lot of college students don't actually understand this topic either. Oh, yeah. So anybody is welcome to download the lesson plans that we developed as part of this. Here's a poster that gives our research results. So the first thing that we did was, a lot of people were skeptical that WorldWide Telescope could be effective in the classroom, and I think a lot of it had to do with this issue where grown-ups are a little bit afraid of the program, and they transfer their own nervousness around it to what students would experience, and they think, well, this is the thing. So we had teachers said, well, this is the thing that we're using, and that's pretty simple and straightforward, and students understand it, and this is what we like to use. So we compared that with WorldWide Telescope. So we had 2 different kinds of activities. One is sort of your traditional ball and lamp model, and then we had a computer model that they used to also supplement what they were doing with the styrofoam ball and lamp. And the students who had, sorry about the sirens going by my window. I'm just going to wait for them to go by.
Oh, good. Tonight. Stay alive. Okay, I think they're gone.
So basically, the students who had WorldWide Telescope had a lot more fun. So on the last day, after they finished their post-assessment, the kids who finished early, they were given a choice to sit around and read a book or do their homework for another class, or to get back on the computers and continue exploring the computer program that they used. And nobody who had done this wanted to get back on the computers. All of these kids were sitting around reading books and doing their homework. And every kid who had used WorldWide Telescope was wanted to get back on the computers.
Wow.
Maybe there were 2 or 3 kids per class that wanted to do their homework, and that was fine. You know, we don't judge. But you know, it was a striking difference. And these kids who used WorldWide Telescope had higher gains on the pre to post assessments. So then after we did this trial, this comparison at the school where they were using this older thing, after we finished that, we were not actually able to get any more teachers who were willing to do this comparison. When we showed them both, they're like, yeah, I don't think my students would feel left out if they were in the group that had this and not this.
Oh, they don't want to be the control.
Yeah, nobody wanted to be the control, or nobody wanted their students to have to be the control. And now that I've zoomed out, I'm not sure how to zoom back in of this page here. I'm not on a computer that I'm normally on, so, well, that's okay. So anyway, so we started asking questions like, well, does it make a difference if they do the ball and lamp first, or if they do WorldWide Telescope first? And all of the teachers, and myself included, we all thought, well, you kind of want to start simple and then work your way to the more complicated thing. So I had thought that it would be more beneficial for students to spend the first day doing the styrofoam ball and lamp, and then the second day doing WorldWide Telescope and getting kind of a more detailed feel of what's happening with the Sun, Earth, Moon system. And the data that we got actually ended up showing that the students who had WorldWide Telescope first ended the whole study with fewer misconceptions. And we are still gathering more data to really understand why that is, but we think it has something to do with the fact, it could be a combination of things, but there were a lot of students who, when they were doing the ball and lamp model, actually didn't understand enough about how the Earth moves and how the Moon moves to really effectively use their model. Like, there were some kids who were kind of rotating their foam moons around their heads in a vertical circle instead of a horizontal circle. There were a lot of kids who didn't get how the motions were supposed to happen.
Right.
And I think those students are helped by seeing it all in WorldWide Telescope first, and then when they get to using the model, then they have a better sense of what it's supposed to do and what it's supposed to look like. And then we also had kids on the other end who were like, yeah, I've done this foam ball and lamp thing. I did that in 4th grade. And they basically just blew off the activity on the first day because they felt like they already knew it all. But really, I mean, they didn't know it all. They just thought they did. Whereas those students who use WorldWide Telescope first kind of came to richer questions that they were able to try and use the foam ball and lamp to answer.
Okay.
So, I mean, basically the upshot is that all of the kids really liked using WorldWide Telescope. And we asked them, you know, did you like the foam model better? Did you like the computer model better? And most of them liked the computer model better, or thought the models helped equally. Only 13% of the students thought that the styrofoam model helped them more.
Okay.
Most students liked getting the foam ball first and then getting WorldWide Telescope, or said that the model order didn't matter. Very few students preferred having WorldWide Telescope first and then getting the foam ball, even though that was the combination that our data shows helped them to learn the best.
Interesting. Lunar phases in my college class. I'm teaching elementary school teaching free service elementary school teachers.
Yes.
We did both computer and ball and stick, and yeah, I didn't even think about how to do the order of it. It's like, let just do everything.
Well, what order did you have them do?
Actually the activity I was working from, so the curriculum already exists for the class, had them using a computer model. I threw in the ball and stick later. They have to do it, and I gave it to them second. And you know, there was I don't know, they haven't been tested on it yet, but
you know, I think
a lot of once they did both, there was a lot of
exactly. I think you can't really effectively teach many people using only one method, because different people respond to different things, and when they've seen both, then it really comes together in their minds in a different way. So I think this would actually be a great tool to use with pre-service teachers. I actually got a lot of feedback from our teachers who field tested this lab for us, who said, you know, I'll be honest, I actually didn't really understand how this all worked, and I used to just teach the matching up the pictures with the names because that was all I knew how to do, and the whole modeling to understand what's actually happening, like they'd never done it and they didn't know how it worked. We got kids to the point where you know, if you ask most people, what time does a new moon rise and what time does a new moon set?
Yeah.
You get the knee-jerk reaction that the new moon rises as the sun is setting and it sets as the moon is rising. I mean, as the sun is rising.
Right.
And there were a lot of students who were kind of the ilk that, oh yeah, I did this in 4th grade, who were saying that incorrect thing, and we gave them the different models and we made them sit down and work it out, and it was a very powerful experience for them to realize, oh, the new moon rises when the sun rises, and they were very excited to be able to figure that out. And a lot of the teachers felt the same way too, that just you have a much richer experience and you're able to use the model to explain all kinds of phenomenon. Like I had teachers whose students, they were asked to actually plot and track rise and set times for the moons over the course of like multiple months, and they were still saying that the new moon rises when the sun sets. Well, didn't you make that chart that says that the moon rises at 8 a.m. and you're not thinking about that? And a lot of those kinds of exercises are just like rote activities where they're not really thinking about the science, whereas when you have the model in your hand or on your computer to explore, then it changes things for those kids, and I think it's a very powerful thing.
So if you want to come back from screen share, we're just about ready to wrap up. Yay! Okay. I just want to say we have one hello from a teacher in Portugal. So hello and welcome. Do you have any advice for teachers on wanting to implement some aspects of WorldWide Telescope in their classrooms?
Yes. So I think one of the things is to just kind of be flexible and go with the flow, because all kinds of strange things can happen when you've got like 25 kids on the computers all at once. And one of the trickiest things is making sure there's enough internet bandwidth for the entire class to be going to the data servers all at the same time. So it can help to cache in advance the things that you want them to look at, so they're not all kind of hammering at the same time. If you go to our website, we have links, the resources for educators. Let's see, I'm not sure where we've put everything on our new, so we have some lesson plans. So you can download the Moon Phases activity. We have an activity that we designed for middle school students on stellar evolution. This intro activity, I think, is probably one of the easiest ways to get people into WorldWide Telescope. So it's basic. Oh, I didn't talk about tours. Oh no.
Go ahead.
Okay, go ahead. Okay, thanks. So let me go back to my screen share, entire screen share. Okay. So basically what a tour is a preloaded view. Oh no, I'm not going to have that one on this side of the computer. Let me just download it from the website I was just at. So let me hope this is all working. So if I download this tour, then I go to the folder where it is. So I can double click on this, and this is a pre-programmed path through WorldWide Telescope. So you can put words on the screen, you can put instructions to the students. So the first thing that students do is they have instructions on how to navigate. So left click and drag to move around in any direction, roll the mouse wheel forward and backward. Okay, once you're happy with that, you click here, And then this takes you to this menu that we've created that will walk you through a lot of the different views that I just showed you. So if you kind of remember that you could get to the coma cluster, but you don't remember how to do that, you can go to download this tour and just click on this, and it will take us to the coma cluster.
Pat, can teachers create their own tours, or do you have
Absolutely, absolutely. And another thing you can do is you can take the tours that we have made, and if you like what we did, but there was like 2 things that you would change, you can actually save your own private version of that tour, make whatever changes you want, and then use your version instead. So let me show you how to do that. So if you go to this guided tours link, it's going to kind of go through the internet to grab all of the different tours. They're somewhat loosely classified by these categories, but this was done by somebody at Microsoft who may or may not have been an astronomer, so some of the classifications are a little bit strange. So asteroids is under cosmology.
Awesome. What even?
Okay, so I like this on Galileo. So so they can be narrated. There's music that you can attach to them. Let's see. Here's Galileo, blah, 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 blah. And so if you want to pause the tour, then you can press the space bar and that pauses it. And what I can do is if I click on this little triangle under guided tours and I go to edit tour, then I now have my own private copy that I'm working with. And I can change whatever I want to change, and then I can save it, and then I have my own version. So if you do this as an educator and you make awesome tours that are really great for your students, we would love, love, love for you guys to share them back with us so we can post them on our website, and other educators who want to teach the same topic don't have to build their own thing from scratch.
That's amazing. I imagine there's probably some students that make their own tours also.
Yes. So we actually did this as a project with 6th graders, where they had previously done projects where they made PowerPoint presentations or like poster board presentations for each other around topics that they had researched. And when the teacher saw WorldWide Telescope, she said, "Ooh, let's do this instead."
That's what I would have done.
Yes. The students loved it, loved it. And we're not doing that anymore at this particular school because it ended up being, well, the other middle school across town, their standardized test scores on the science are a little bit higher than ours, and we're feeling squeezed to really get content in. So that's one of the reasons why we ended up developing the moon-based curriculum, because that's a way to get students exploring and learning using these kinds of tools, but to teach something that their teachers would have had to do anyway. So it's all good, and we're talking with that other school now about moving the tour making into an extracurricular club. So it's all good.
One last quick question: are there any tutorials, video tutorials about?
Yes. Okay, so if you go to the worldwidetelescope.org website, there's a lot of detailed instructions there. We've tried to distill the most critical things that we feel people should know. Where did I put all those things? Get help. How about that? I actually don't remember how we reorganized our stuff. Okay. Learn to use Worldwide Telescope videos and tutorials. So this is installing Worldwide Telescope basic features. I think we want to keep working on reorganizing this. This isn't quite how I would have expected to find all of this material.
We know how that goes.
Okay, so how to animate objects, how to so this is like a lot of the tour stuff, and I think this kind of got out of order. I'm going to need to go and fix it. I mean, we literally just launched this new site like days ago. But yeah, if you click around, you'll find a lot of the basics. One caveat that I'll just mention is that a lot of these tutorials were made like 3 or 4 years ago, and as they keep releasing new versions with new features, some of the controls look different now. And if you find that you're looking at a video that really doesn't match up with how things are now and you're totally confused, it would be helpful if you alert us to that as well.
Cool. Awesome.
Okay.
Awesome. Well, thank you very much. I know
Wonderful.
I want to, so you guys over at the Microsoft Research Center in Boston hosted a astronomy recently. It was last year's, I think, or the year before. No, it was last year's.
Yeah.
And there are a large number of astronomers who showed up with their Macs. And a large number of astronomers were installing Windows on their Macs just so they can develop a worldwide telescope because it's so freaking cool. So thank you for sharing that with us. As long as I have enough hard drive space, I can install.
You can do that.
Yeah, so my computer gets back finally.
Right.
Yeah. So thank you so much for sharing that with us.
Yeah, thank you for having me. This was really fun.
Yeah, and we're getting lots of thank yous and fun in the comments as well, so people really enjoyed this demo, which is excellent. So now we know what you're going to be playing with when you go home tonight from work, you guys.
Yes, after work.
After work.
And if you run into issues or problems, you can't figure out how to make it do what you saw me do today, you can send me an email. I'll do my best to help.
Yeah, so we put your Harvard email up on the event page in the comments, so you guys can check that out and look for new exciting things to come from WorldWide Telescope soon.
Absolutely.
Cool. Well, thank you so much for joining us. Today is Wednesday, so the Hangout schedule I'm like thinking, what day is it?
It is Wednesday.
If you're watching this, we'll be back next week with a new topic that I already forgot because I didn't do the website since yesterday. So we'll have Learning Space next week. We have Fraser Kane is hosting the weekly Space Hangout on Friday at noon Pacific, and Astronomy Cast is at noon Pacific on Monday. And I think Pamela and Fraser are continuing their Women of Astronomy series, so tune in for that. So that's our upcoming Hangout schedule. So thank you guys for watching. Feel free to email us at educate@cosmoquest.org if you have any questions or suggestions for the show in the future. We'd love to hear that. That's pretty much all the things. Yeah, thank you again for joining us.
Thank you.
Bye, Pat. See you next week.
Bye.
Bye.
Okay, so there are many different views, and the default view that you see when you launch the desktop client in Windows is this view of the solar system. Now, it was named the solar system view back when it only had the solar system. And then once they built the 3D engine to render this model, this fully accurate model that works in real time, so this is where everything in the solar system is at now, this point in time. They realized, oh, we have the Hipparcos catalog of stars where we have accurate parallax measurements. We could throw those in. We can throw in a beautiful model of the Milky Way. We can throw in galaxies from the Sloan Digital Sky Survey. So I'll gradually step outwards and show you all of those things. I can also show the sky view where you can look at the entire electromagnetic spectrum, all sky, and then there are panoramas from Mars and the Moon, and there are really beautiful Earth-based and other planet-based views. So let me just start here. If you click on any of these thumbnails at the bottom, it will take you to objects of interest. I find that a lot of people are really happy just starting at home.
Nice and familiar.
When I give these demos, especially I find the younger the students that we work with, so we do a lot of these kinds of demos at public events like science festivals. We do a lot of work in classrooms, and every kid eventually goes back to trying to find their house. But
all different Google Maps first came out, or Google Earth.
Yeah. So the Earth-based views get compared.
Pamela wrote a blog post fairly recently about the funding woes going on across various NASA programs. So if you can help out, check that out.
Yes.
I can tease maybe that we have a Patreon account starting soon, which will help fund some of these video broadcasts.
Yep, exactly.
So we'll be doing that.
So keep an eye out for that.
Anything else? Announcement-wise?
That is really the big concern at the moment. So, to put it that way. Yeah, I think that's it.
Okay, cool. And so today we are going to be talking about WorldWide Telescope. We have Patricia, and I forgot to ask you how to pronounce your last name before we went live.
It's Udon Persert.
Udon Persert. No. I didn't do it right.
Wow.
Udumperson. I shouldn't be talking. My last name's Gugliucci. But
You're saying that I wasn't sure how to say yours either.
So thank you for coming on the show. We wanted to show people a little bit about WorldWide Telescope and specifically ask about how that works in the classroom for educators or with the WorldWide Ambassadors Program. Before we get into that, I want to remind you guys that you can use the question and answer app, the Q&A app, anywhere you're watching this on YouTube or Google Plus or anywhere that it's embedded. I forgot to embed it on the CosmoQuest site. I think it's over here, somewhere over here, somewhere over here. One of these places, there's a yellow button that says join the conversation, and you can click there to join the Q&A app. And leave some questions. So we have hellos from Nancy and Guido and Elon. So hi, everybody.
Hi there. Good to see everybody.
There's also usually some general chatter happening in the comment threads on the event pages. I will try and check in on that every once in a while. But if you want a question or a comment, for the show, make sure you use the Q&A app. So why don't we jump into the topic, Patricia? What the heck is WorldWide Telescope?
Got it. Okay. So WorldWide Telescope was a program that was developed by Microsoft Research, and it's designed to visualize all of the imagery that astronomers have ever taken with telescopes all around the world. And it was released in 2008, and it's grown and grown over the last 6 years to include many powerful and exciting features, which makes it a wonderful tool. It can be overwhelming to some people to learn. 12-year-olds in classrooms, we find, are not part of the group of people who feel overwhelmed by it. They just jump right in. They think it's amazing and awesome. We have a 12-year-old boy who said in front of his entire class, wow, this program is cooler than Call of Duty.
Ooh!
So,
wow!
So let me jump in right here with a screen share so I can start showing and not just telling. See if
so you guys know
share my screen. WorldWide Telescope is not coming up as one of my choices for what I'm allowed to share right now. So,
is it full screen on one of your desktops?
I don't think so. Hold on. Let me try this again. Sorry.
That's fine. It's worldwidetelescope.org, and we've got the link in the Showcase app right now.
Super. Okay.
Hey!
Okay, there we are.
There we go. Oh, for crying out loud.
What are you doing?
I don't know.
I'm talking to the computer.
We're talking to the computer. Okay, there we go. Now we're back. Hi, everybody. Welcome to this week's Learning Space. We are your hosts, George and Nicole. We are all together in one office because my computer's still gone with a dead hard drive. Very exciting. So welcome to this week's Learning Space. First off, I want to thank all you guys who have been donating or sharing or retweeting our Giving Tuesday requests. We're still getting some donations in, which will help us out greatly. So thank you. Awesome. If you haven't already, check out the